Location Legends, it's Prof. G, and in this lesson we're going to use the Location Manager class we created in the prior lesson to add Place Lookup. So our user will be able to enter a place into the search bar, and we'll have our app make suggestions on places with names that match that entry. Let's locate the big learning. At the end of the last lesson, we built a Location Manager class in SwiftUI and used this to get the device's location. Now we'll use that Location Manager class to search for places and return details about a place, including name, address, latitude, and longitude. So I'm in the content view file, and we're going to launch our Place Lookup view as a full screen sheet. And to do this, we need a Boolean value to trigger when the sheet should be shown. So at the top, we'll enter @state private var show Place Lookup sheet lower camel case equals false. And we're going to add a bottom bar toolbar so that we can add a Place Lookup button in that. And before we can add a toolbar, we need to embed our VStack in a navigation stack. So to do this, I'll command click on VStack. There's no embed in navigation stack, but I'll embed in ZStack, then replace ZStack with navigation stack. And inside the navigation stack, just below the padding modifier for the VStack is fine. I'll add .toolbar with content, press return for trailing closure, and inside I'll add a toolbar item view. I'm going to hold down the option and press return to add the placement and content inputs. And for placement, I'll add the .bottom bar, tab over to content, press return for the trailing closure format, and inside these curlies, I'll add a button with action and label, press return for trailing closures, and I'll clear out the action for now. And with the label, I'm going to pass in an image with system name and the string magnifying glass, all one word, all lowercase. And I'll add a text view below this, passing in the string lookup place. And I am ready to add an action for this. I'll just add the action show place lookup sheet.toggle. And then I can add the sheet just below the third to last curly in the struct. I'm going to enter .full screen cover with is presented, and content is presented should be a binding value $show place lookup sheet. Then I'll tab over and press return for the trailing closure, and I'll put in a to do comment in between the closure, show place lookup view. Then we've got to create the place lookup view. So I'm going to do this by right clicking on the content view in the project navigator, selecting new file, SwiftUI view, and I'm going to name this place lookup view. Now, since we're about to create one of those .searchable search fields, we're going to want to create a value to hold the search text. So we'll do this with @state private var search text, setting this equal to the empty string initially, and we're going to eventually want to dismiss this view. So we'll create a dismiss with @environment and in parens \dismiss, followed by private var dismiss. And we're going to show the results in a list, but just so that I have something to show in the list for starters, as I set up my user interface, I'm going to create a string array for now with var places equals, and between brackets, this will be a string array with the strings here, comma there, comma everywhere, comma and East Jabib. Then in the body, I'm going to create a navigation stack, which I need because I'm going to be adding a searchable search bar. And in the navigation stack, I'll add a list with data ID and content. The collection will be places, ID will be \self. I'll tab over to content and press return. We're going to pass in place, and inside this, I'm simply going to add a text view with place inside of it, and I'm going to set the font to title 2. Then below this, I'll set the list style with .list style passing in .plain. Below this is also where I'm going to add .searchable, passing in the text $search text. It's got to be binding. And I also want to add a dismiss button as well. So I'm going to add a .toolbar with a toolbar item view in there. I'll hold down option selecting the placement and content. The placement is going to be .automatic. I'm going to tab over to content, press return. I'm going to add a button with title and action. The title is going to be dismiss, and the action is simply going to be dismiss, followed by parens. And now we can head back to the content view and try this out. And when I click on lookup place, I don't see anything, and that's because I didn't present the place lookup view. So I'll get rid of the comment in my full screen cover, and I'm going to just enter place lookup view, and this now works wonderfully. Search field doesn't yet do anything, and dismiss gets me back to my content view. Nice. Now let's add some code to get this interface to actually do something. And now let's create a model to hold data on each place. I'll do this by right-clicking on the app file, that's the Place Lookup demo app file, selecting new file, Swift file, and we'll call this P place. And we're going to be working with portions of the MapKit library here too. So I'll start off by adding import MapKit. Then we'll set the struct to the name place, P, colon, and it's identifiable, open and close curlies, and we'll create an ID property with let ID, that's in lowercase, equals capital UUID parens, .UUID string. And we're actually going to have only one stored property in this struct. It's going to be a value of type MKMapItem. But MKMapItem types have lots of additional data on a given point or place. And we're going to use the data in there to deconstruct and get at the specific items that we want. Now, we're not going to be accessing this MKMapItem outside of this struct, so we'll declare it as private with private var, name it map item, lower camel case, colon, and this is of type MKMapItem. Now, code completion says this is a point of interest on a map, but this is a very complex data type, and there are lots of properties in here that we can interrogate to get individual pieces of information about a point of interest. And now we're going to be getting back MKMapItems from our search, so we'll create an initializer to pass in new MKMapItems to create a new place. And I'll point out when we work with a view model where exactly we're calling this initializer, but we're going to do this with init, open close parens, and in between the parens we'll say mapitem colon MKMapItem, follow this with curlies, and inside we'll say self.mapitem, that's the property of the class here, and we'll set that equal to mapitem, which is the value that we pass into this initializer. So again, this is just code to set up a new place using a map item that we pass in here. Then we're going to create several computed properties. These are values that are computed based on components of the map item. So we're going to start out with var name colon string, open and close curlies. And this is a computed property, so whenever we refer to the name, we'll return self.mapitem.name. So this actually gives us the name of a place. So .name is a component of an MKMapItem, but we might not actually get a name here. This is a string question mark. So if there's a chance that we don't get anything in here, we need to deal with a possibility of nil. We'll add a double question mark for nil coalescing, and if it is nil, we'll follow this with an empty string. Then below this, we're going to calculate the address value. Now this is going to look like some complicated code, simply because there are lots of different ways addresses can be expressed worldwide. We might also get back an address that does have a street number, that doesn't have a street number. If we have street number address, it's usually street number space address, but if we don't have a street number, then it would just be address with no space. So I'll try to describe each step as we construct what we're going to return for the address, and this will hopefully generate what I think is going to be a useful and usable address for us. And hopefully what I'm going to describe here is going to be understandable enough so that if you need to tweak this on your own, you're going to be able to do that. So again, this is going to be a computed property. We'll start with var address, the name of the property, colon string, that's our type, open and close curlies. And up top, when we have one line that we're turning into a computed property, we don't need to use the keyword return, but here we're going to have multiple lines inside, so we will need to add a return keyword right at the end. But before we get to something to return, we got a lot of code to write, and we're going to be working with something called a placemark. Now, a placemark actually contains lots of additional properties that we can access to get detail on a specific place. So a placemark is an APL type, and it's often used when gathering data on a specific location. So we're going to say let placemark equal self.mapitem.placemark. Now, this says that this is an MKPlacemark. That means it's a MapKit placemark, but this type is actually identical to another thing you'll hear called a placemark. That's a CLPlacemark for core location placemark. CLPlacemarks and MKPlacemarks are the exact same thing. You can use those terms interchangeably. But if you want to find out more about placemarks, you can look up Apple's documentation on CLPlacemarks online. Here you can see all these different properties that we can have access to. So there's thoroughfare, which says street address, sub-thoroughfare, which is additional street information. Now, unfortunately, sometimes the information in the documentation isn't super helpful. So in many countries, like in the United States, the sub-thoroughfare is actually considered the street number, the number of a particular location, while the thoroughfare is the name of the street. So in the code we're about to write, we're actually going to assemble the street address by putting the sub-thoroughfare first with a space followed by the thoroughfare. That should give us the street number, space, then the name of the street. Now notice locality is city, administrative area is state, so feel free to explore this more on your own if you'd like. And remember, to find out more, you can always use print statements and run this in the simulator if you want to print out the different components that make up a CLPlacemark. Or you can put in breakpoints in your code, and you can look at properties when your code is paused and check those out individually if you need to see what data is in the individual components of a placemark. Now back in our code, we are going to create a city and state, which I'll create as a variable, initially setting this equal to empty string, and we'll eventually add this to an address that we'll construct as a variable that we initially set as an empty string as well. And we'll start out by saying city and state equals placemark.locality, and you can see code completion says this is a city, and it's also optional. See the question mark at the end? So we need to deal with the optional. We'll use nil coalescing, double question mark, passing in an empty string if we get a nil for locality. Then let's try to get the state. We'll say if let state equals placemark.administrative area. Now there's a question mark at the end here too, so this might be nil, which is why we're using if let here, followed by curlies. And in here we'll show either just the state if we don't have a city, or city, comma, space state if we have both. And we can do that with city and state equals city and state dot is empty. So if there's no city, then question mark. So we're using the ternary operator in here. And if this is true, we'll pass in state colon, but if this is false, we'll pass in double quotes, string interp, comma, space, string interp, and in the first string interp, we'll say city and state, which right now is just city, and in the second string interp, we'll pass in state. So now inside of city and state, we should either have city, comma, space, state, or just state if we don't have a city. And just to silence this error here, remember we have to return something in this computed property because we've got multiple lines, so I'll say return address below. But we've got more things to enter above this return statement first, so in here I'll say address equals placemark dot subthoroughfare. Now again, the description and code completion isn't helpful here, but this is usually, at least for Americans, the street address number. And again, it can be nil, so we're going to follow this with double question mark and empty string to deal with the possibility of nil. I'll add a comment in here that says that this is the address number. Then we'll get the street name if let street equals placemark dot thoroughfare, and code completion says this is the street address, but I don't think that's very accurate, and it's actually the street name without the street number in most streets that you would see in North America. Notice this value is also optional, which is why we're using if let in here, and then we'll follow with curlies, and we're going to write code inside of this just to show the street unless there's also a street number, and if so, we'll show the street number space street name, and we'll do that with address equals, and like above, we'll use the ternary operator, address dot is empty if we don't have an address, and up till now that's just the street number. Then we'll just pass back street, so that's question mark street, which is just the street name, colon, otherwise, and in between double quotes, we'll have string interp, space string interp. First string interp will be address, which is our street number. Second string interp will be street, which is the street name. Then I'll check to see if the address is empty, but the city and state are not. And if that's the case, then we'll just set the address to city and state. So we'll do that with if address dot trimming characters and select the option within, passing in dot white spaces. So this is going to get rid of any blank spaces that are in the address. Remember, we learned about this technique in the Word Garden app. Dot is empty. So if we got nothing in the address after trimming out all of the white spaces and double ampersand, we'll say city and state dot is empty, but I actually want this situation where we're not empty. So I'll put in an exclamation point out in front of this, then open and close curlies. So in this case, we got nothing in the address, but we do have something in city and state. And what we want to say here then is address equals city and state, so we don't have any space or commas in front of this. Else, open and close curlies. So again, up top, this is the case where if we don't have a street address, then the address is just going to be the city and state with no space out front. Otherwise, in the else clause, if we don't have a city and state, then we're just going to pass back the address. Otherwise, it's going to be address, comma, space, city and state. And we do that with address equals city and state dot is empty. Again, we're going to use our ternary operator, question mark. If we don't have a city and state, then we'll just pass back address, colon, otherwise, double quotes, string interp, comma, space, string interp, address in the first string interp, city and state in the second string interp. So now we've got our address built up. So we have lots of different possibilities for how we could construct our address if we have different components or they're not there. Hopefully this is going to return exactly what we want to show up in our address field. So with address set up, we also want to get back the latitude and longitude, which we'll eventually use to plot a place on a map, and we'll do that in a future lesson. So right now we're going to add calculated properties for both of these things. We'll start off with var latitude colon double. So a latitude and a longitude are double values. Those are numbers with decimal points in them. Open and close curlies, and we'll return just one line here. Self.mapItem.placemark.coordinate.latitude, but look at this. Code completion says the type for latitude latitude is CL location degrees. But hey, up here I said that this is supposed to be a double. Well, watch what happens when we replace the word double up here with CL location degrees. Oh, down here in code completion it says CL location degrees is of type double. So CL location degrees is what we would call in Swift a type alias. It's just another term that's the exact same thing as the other term. So a double is the exact same thing as a CL location degrees. So even though this is a double, if you're a developer and you're looking through types in your code and you see something as a CL location degrees, it provides that extra reminder that, oh yeah, this could be a latitude or a longitude. Do know though, you could use double or CL location degrees and they really are the same exact thing. It doesn't matter what you put in here. Most developers would probably think CL location degrees is a little bit better because you give a little bit more information saying, hey, this is going to be a longitude or a latitude. Then I'm going to copy this latitude computed property I just entered, paste it below, and change latitude in 2 places so that it reads longitude. And that's it. Our place model has been set up, and curiously, we actually have only one stored property in here. That's the map item, which is an MK map item. We just compute all of these other values in here from that single map item. So now let's create a view model to work with this model. So let's put this under place model. We'll right click on place, new file, Swift file, and we'll name this place view model. And we're also going to import mapkit here, and we'll set the @main actor just so that we don't get any of those purple errors that show up if our code tries to run user interface updates outside of the main thread. And then we'll declare our class with class place view model observable object open and close curlies. And we're going to keep track of an array of places here. That's our struct place. And we'll use this simply to return the places that the user searches for. So we'll say @published var places square brackets capital P place inside there equals empty square brackets. So it'll have nothing in it initially. And now we'll create a function or a method in this class that will search for a bunch of places based on the text that the user enters into that searchable search field that's on the place lookup view. So we'll say func search parentheses, and we're going to pass in 2 values here. Text, which is a string, comma, and region, which is an MK coordinate region, open and close curlies. And then the first thing we need to do is to create a search request. Now we'll do that with let, we'll call this search request equals MK local search, which is an object that's required for setting up our search. And then we'll say dot request with open and close parens, and this sets up the local search object for us. So now that we have that local search request object set up, we're going to configure it with search request dot natural language query, which is the string that we're searching on. So we're going to set this equal to text, which we pass in, which is the text the user enters into the search field. Then we set the region for the search request with search request dot region, and this is going to provide a hint as to what we should be searching, although you can search outside of this region as well. Now this is useful if you search for something like Starbucks or pizza. There are tons of those and way more than you want to report back. So our search results will favor results that are in the region that we pass in here. And while you can get results that are outside of this region, it won't return all of the results outside of the region. So Apple's documentation refers to this as a hint for the search that's to be performed with the search request. And again, we'll just set this equal to region and we pass that into the search function. Next, and I know this is going to look weird, but we'll set up our search with let search equals MK local search. Then we're going to select the option with parens and the request inside, and the request that we're going to pass in is the search request that we just set up. So this actually sets up what's called the search object to execute the search request or the search that we've passed in using the text that the user typed into the search field and the region so that we can limit things. Then to execute this search, we simply say search.start. Now we're going to select the option with the completion handler, and let's press return on the handler. And we get 2 values here that could potentially be returned back, but we can see that those are optionals. We might not get these. In fact, if you get one, you typically don't get the other. So we'll call this first one response and the second one error. Then in between the curlies, we'll make sure that we have a non-nil response with guard let response equals response, else open and close parens. So this means if we get a response that's not nil, then we're going to unwrap it. We're going to put it in a value called response, and for the rest of the function, response is going to be that unwrapped value. And if we get a non-nil response inside the curlies, we're going to print angry emoji, error, string interp, passing in error.localized description, double question marks, followed by the string unknown error. But frankly, we should never arrive here with an error that's nil. And be sure to add a return inside the error curlies. But if we get a response, the response is actually a list of MKPlace items. So we'll put those inside our places array with self.places equals response.mapItems. And look at this. This is an array of MKMapItems, and that's the value we pass into our place struct with the initializer we set up. So to do this, we're going to say .map. Now this map here has nothing to do with maps as in maps of geography. Instead, this is a higher order function in Swift. So this .map here is not a MapKit map. It's going to return an array by applying the code that's passed in between the parentheses. Or mapping, meaning evaluating one by one each element in the array, transforming each element and creating a brand new array with whatever statement we put in between the parentheses. So again, this is a higher order function, just like for each and filter. We've already dealt with those guys, so this is just going to prevent us from having to write a for loop and looping through all of these values. You could certainly write a for loop if you wanted to, but we can get this done in one line. And what are we going to map in here? Well, we'll just call place.init. And look at this. This is the initializer that we created inside of our place struct. And what'll this do? Well, it'll take each MK map item in the map items plural array. And remember, this comes from the response or the result we get from applying the user search criteria. And it'll use this one by one to create a new place element and add this into an array called places, which is the published array of this class. And just to show you, if I head back to our place struct, see this initializer here that we created? I said I'd come back to this. Well, this is what we're calling. We're calling this inside of that map function, one by one, passing in an individual result in the array of results that we get when we put our search term in the search field and press return. So now we'll have a result of the user's search. Let's head back to the place lookup view and make sure that these places are displayed in our list. Now, when we call our search function that we just created, we're going to pass in a region to act as a hint, as Apple puts it, in getting back more accurate search results. And from our prior lesson, we actually created a region in our LocationManager class. Now, also in the prior lesson, we set up that LocationManager class as an environment object in the app file, but we need to refer to it in the place lookup view as well. So at the top of the place lookup view, we'll say at environment object var LocationManager lower camel case colon LocationManager upper camel case. And again, we're declaring this no parens after this. We're not initializing it. It's already been initialized as a state object. And we also need to use our place view model. And since we're only going to be using that in this view, we don't need to create an environment object for that. We can just declare this as a state object with at state object var place vm equals place view model. And we do want open and close parens here. We are initializing this as well as declaring it. And again, we can initialize this with state object here if this is the first or only place that we'll be using this view model. Now we no longer want this array of places. We have a published array of places of type place in our view model, so we can delete these old places that we just used to set up our user interface, and we can update our list. We can delete what's inside the parentheses of the list, and we can pass in instead placevm.places. And each place is identifiable, so we no longer need the ID parameter in here. And in the text view, I'm now going to pass in place.name, and I'll also show the address for each place returned just below this text view. So I'm going to command click on the text view to embed this in a VStack, and then below the text view inside the VStack, I'm going to say text passing in place.address, and I'm going to set the font to .callout. And I also want to make sure that these results are left justified in the VStack, so I'm going to add parens after the VStack, and I'll specify the alignment colon attribute label here, passing in .leading. And now let's use the search method that we created in our place view model. That'll give us our results. So we do this by using a .onChange modifier. I'm going to put this just below the searchable field. It doesn't really matter where I put this, but I think that's a good spot for it. And here we're going to select an option with of and perform parameters. The of will be our search text. So what this is going to do is it is going to call this onChange modifier whenever anything is modified inside the search text. So for example, whenever the user types a new character in that search field. Then we'll tab over to perform. I'll press return here. And why don't we refer to the new value as text? And then inside the closure here, we're going to say if text dot is not empty, open and close curlies. And to make sure it's not empty, I've got to add an exclamation point in front of text dot is empty. So that means I've got something inside the search field. So I'm going to call placevm.search passing in text and the LocationManager.region as my region. Again, we set that up in the prior lesson. So this should update our places array in the place view model, which is published and which should update our list automatically. Else, if we have an empty string in the search field, then we'll just set placevm.places equal to the square brackets of an empty array. And if I try to run this in the simulator, we get a very unfriendly error. Can you guess what this is? We didn't update our preview provider with the new environment object that we're now using in this view. So down below in the Place Lookup view in the preview provider, just below this we'll add a .environmentObject modifier, passing in LocationManager, open and close parens. And the error goes away, and I'll start type whatever you want. I'm going to type in Boston College, and slap my search field. Will you look at that? We can see all of these results showing up in our list. Just dynamite. And we can clear out that search field with a little xClear control. The list is clear. We got nothing in there. You can type something else. I'll type in El Pelon, which is that popular taco spot by Boston College. We see 2 results for El Pelon. One of them is on Commonwealth Avenue. That's the one right across from the university. So this is fantastic. You can also try this from the content view. Click the Lookup Place button. Full screen cover's presented. I'll say Shake Shack Chestnut Hill. I get the Shake Shack closest to me. You can also try this out in the simulator if you'd like. Now, one thing that you will notice, Apple does limit the frequency that these searches can be performed. So if somebody types very quickly, you might see a delay in the results that you're seeing in here. If you take a look at the console, sometimes you'll also see this in the form of errors that print out down below. You might see, for example, error code number 3. That just says that there are too many searches being performed. Don't worry if that shows up. Frankly, there is a way that we can slow down sending search results out to Apple so that we won't get that error. To do that, we'd use a technique called debouncing. It involves some more coding. Now, I might return to this in the future and do a debouncing lesson as well. But for now, since there's so much more we want to cover in the semester, I think this actually works pretty good, and we should be happy with what we built. Finally, I want to demonstrate how we can modify our code so that we can click on a search result and pass it back to our original screen. So here in the content view, let's create a place value that can hold the result we want to send back. So we'll say @state var place equals P place, and we'll pass back an MKMap item, initializing this with parens. This is just going to set up an empty value at first, and oops, Xcode informs me that I need to import MapKit if I want to use this, so I'll let Xcode fix that. Thank you, Xcode. And you know what, just that we don't confuse things, why don't we refer to the place that I just set up as returned place to distinguish this as the place that's being returned when the user clicks on a location. And I'm going to enter something a bit awkwardly. I haven't added the returned place to my place lookup view, so I'm going to get some errors in here. I'll eventually add that to the place lookup view, but I want to pass in the returned place. Now, we also want to make sure that any changes to return place that happen on place lookup view are going to be reflected back here. So I'm going to add returned place : and then $returned place. So that makes this a binding value that ties the returned place that's on our child view to the returned place that's on this parent view. Changes happen to return place on the child, those are going to be reflected back here on the parent. We'll see how this works in just a bit. And also above, where I've got our text view, I'm going to add one other text view to show the return place with text, passing in the string returned place : \n for new line, name : string interp. And my code completion doesn't seem to be working well. It's likely because I haven't created the returned place on my place lookup view, so I've got errors, but I'm going to power through this anyway. In the string interp, I'll say return place.name, then outside of this, another \n for new line, string interp, returned place.address \n, coords for coordinates, string interp, string interp, and I'll pass in return place.latitude and return place.longitude. And just after the first \n, I'm going to indicate this is an address. Then let's head to the place view model and add a returned place in here. And remember, we're passing this in as a state variable from the previous view, the content view. So in here, this is actually going to receive this using a binding value. And that's going to link the changes back to the original state value in the parent. So we can do this with @binding var returned place : P place. And again, we learned this quite a while ago in an earlier exercise, but now we're applying that example here. And again, when we make changes to the returned place on this view, they're going to be passed back to that original state value on the content view on the parent. And now we also need to update the preview provider, and I never find these to be intuitive, but what we need to add in here is to update this with the returned place property that we just added. And for the binding value for place, we'll pass in, again, not very intuitive, .constant in between parens. We're going to pass in the place, which is set up with an MKMap item with open and close parens after that. And I'm getting an error in here because I also did not import MapKit on this view. I'll let Xcode fix that. So again, preview providers are not friendly. Hopefully Apple will update this at some point in the future, but for now, this code will fix that error. It will work, even though it's not very friendly or intuitive. But why we've set all this up is so that if the user taps on a row in the list, we'll update that returned place. So just under the VStacks closing curly, we'll enter dot on tap gesture. We'll press return to get the trailing closure curlies, and in here we'll say returned place equals place. And now this part here is really easy to forget. We want to make sure that we dismiss this view. So we'll say dismiss open and close parens, because if the user clicks on a place, they've selected it. We want to get rid of this view and go back to the parent view, the content view. And my dismiss shouldn't be indented that far, so I'll Command A, Control I to fix my indentation. So now let's head back to that content view. And this error down here is not accurate. Xcode just has to catch up with what we've written, our correct code. But I'll press the resume button in live preview, and we initially see an unknown location in here because we haven't selected a return place yet. But I'll go ahead and look up a place. I'm going to enter Johnny's. I see Johnny's Luncheonette, which is close to campus in Newton Center, a great place for breakfast. We'll tap Johnny's Luncheonette, and holy return value, Batman! We see the name, formatted address, and the latitude and longitude for Johnny's Luncheonette. Nice! You can try this out in the simulator too. You might again notice some errors that print in the console in the simulator. Again, if you get error code number 3, you're sending too many search requests at a time. That means the user's typing very quickly. It's not going to break your app at all. If you see error code 4, that just means that whatever the user typed in can't be found. There's no match when we search things through, but that will change when the user enters something that's valid. So again, we wrote some pretty advanced code here, Swifter, but now we've got lots of code that we can reuse in other apps, and in our next lesson we're going to raid this app and grab code to add to Snacktacular so we can easily look up places to add a spot as a restaurant that can be reviewed in our app. So feel good about those newly acquired skills and stay swifty, my friends.